Good morning. Welcome to Mission Control Houston and Flight Control Room 1 at NASA's Johnson Space Center, where the International Space Station Flight Control Team is on duty 24/7, keeping tabs on space station systems and working with Commander Drew Feustel and the Expedition 56 crew members as they move through their daily agenda of science, research, and station maintenance. This week, the crew members have also spent some time pointing their cameras out the window to share their perspective of disturbances on the Earth, while also getting ready for some upcoming spacewalks and preparing for the arrival of a new shipment of supplies that's due next week.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Gary Jordan. With a careful eye on weather conditions, over 10,000 pounds of science and supplies awaits launch to the International Space Station. The unpiloted HTV-7 cargo vehicle of the Japan Aerospace Exploration Agency, or JAXA, is set to lift off from the Tanegashima Space Center in southern Japan on Friday evening, U.S. time, after delays due to Typhoon Mangkhut in the Pacific. Inside, over 5 tons of supplies, water, spare parts, and experiments, including 6 new lithium-ion batteries that will be swapped out over a pair of spacewalks. The cargo vehicle is set to arrive on Tuesday, September 18th, early morning U.S. time. Because of this, the 2 spacewalks following the cargo vehicle's arrival have been rescheduled for the near future. Check out our website for the latest updates and to tune in to our live coverage. Though much of this week was spent preparing for these upcoming activities, the crew was able to get a glimpse of some severe weather on Earth. From 250 miles above the Earth, space station cameras were able to view Hurricane Florence from directly overhead earlier this week, while the storm was building over the Atlantic Ocean. The astronauts aboard also snapped some pictures with their handheld cameras. NASA astronaut Drew Feustel commented during an interview this week about his view from the station windows.
What we see from up here is a little bit scary because the storms are so massive. Right now, Florence is headed for the east coast of the U.S., and although it is beautiful and amazing and one of the great wonders of our planet, watching the weather change, it is a little unnerving to know that there may be some folks in the path of destruction, and we wish them the best and hope that at least some of the imagery we do or some of the work that NASA does provides some fair warning and analysis of what's going on to better understand how these things occur and the best way to respond to them.
We're getting closer to the first launches of astronauts on spacecraft from Boeing and SpaceX, which means the training has hit high gear. Mike Hopkins recently showed off some spacewalk training that will be vital while he's spending 6 months on station after arriving on the SpaceX Crew Dragon's second flight. Be sure to follow him and his crewmate Victor Glover and head over to nasa.gov/commercial crew for all the latest. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
Now, live coverage of the HTV launch begins at 3:30 Houston time this afternoon, September 14th, on NASA TV and nasa.gov. The launch is targeted for just a minute before 4 o'clock this afternoon. That will lead to live coverage of the arrival of HTV next Tuesday, September 18th, starting at 4:45 a.m. Central Time. And we should see Canadarm2 capture the Conatori at 6:30 a.m. And then we'll be back at 9 o'clock Central Time Tuesday morning to see installation of the cargo ship to the space station's Harmony module. Although your calendar says this is 2018, it's also known as the Year of Education on Station, which NASA has planned as a time to help teachers and their students get the most out of learning about science, technology, engineering, and math. The International Space Station crew members have been talking directly with students on the ground, and they've been making fun instructional videos in zero-G. In this installment of the STEMonstration series, Scott Tingle demonstrates the orbit of spacecraft and offers the viewers a chance to participate.
Hello, my name is Scott Tingle, and I'm living and working on board the International Space Station. You know, I love my views from the cupola. It's our orbiting altitude of around 400 kilometers or 250 miles above the Earth's surface that gives us these unique perspectives. Let's explore how our ISS orbits work. Come on. First, I should explain, orbits are elliptical or oval in shape, with some being almost circular. Planets, comets, and moons have elliptical orbits. Spacecraft orbiting Earth, like the space station, are placed into a nearly circular orbit to keep a consistent altitude as they travel around the planet. Let's take a look at the Earth. It has a radius of 6,378 kilometers, and the station orbits about 400 kilometers above the surface at 8 kilometers per second. That's 17,500 miles per hour. See if you can use these values to calculate how far and how long we travel in one orbit around the Earth. All of this information and more activities related to orbits are available in the accompanying lesson plan at nasa.gov/STEM on station.
Answers coming in.
4, 3, 2, 1.
The answers to the questions, by the way, are approximately 42,600 kilometers and 90 minutes. And due to our altitude on orbit, we have our very unique and awesome view of the Earth. Thanks for exploring with me today. I'm going to send you back to Earth now so you can start your challenge on orbits. See you again soon.
The International Space Station uses Tingle and the other crew members as subjects in an ongoing experiment to learn about how human bodies respond to being in the alien environment of weightlessness. It's information we need if we're going to make future journeys out into deep space as safe as we can for the human explorers. And another important aspect of the station's contribution to education is that it provides a place for experiments devised by students to be carried out. Those two goals were combined for the Genes in Space competition, which challenged students and teachers across the country to design and fly an experiment about the relationship between altered DNA and the weakened immune systems some astronauts experience during spaceflight. Anna Sofia Bogoraev's experiment was up to the challenge.
When I was 4, I told my mother I was going to be an astronaut, so it's kind of been a perpetual thing from there. And I figure if I'm going to be an astronaut, I don't want to be getting sick. And if someone isn't doing what I think about the immune system, why don't I go look at it myself? This is the mini PCR machine designed by Mini PCR. PCR is polymerase chain reaction, so DNA amplification. We now have more DNA amplification capabilities on the station, but when this went up, it was the first.
Hi, this is Tim Peake on board the International Space Station, and this is a message to Anna Sofia to say a huge congratulations for your winning submission to investigate the effects of cosmic radiation and microgravity on the body's immune system.
So you're meant to have a balanced ratio of your T helper 1 and T helper 2 cells, but when you're in space, you get a much more dominant T helper 2 phenotype, which decreases your cell-mediated immunity and just generally hampers your immune system.
Along with being the lab assistants for some of the experiments on the station, the International Space Station crew members are the subjects of some of those experiments. For instance, there's one looking into how the 3 pounds of bacteria in a person's gut impacts their health. Researchers are trying to find out if those bacteria pose a threat to the astronauts on missions out into the solar system.
It's thought that there are 10 times more bacteria in our gut than there are cells in our entire body. There's like 3 pounds of this bacteria in our gut, the size of our brain. We know that the composition of the bacteria in the gut is related to a wide variety of diseases, diabetes, cardiovascular disease. Once we started sequencing everything that was in there, we found we were just shocked. If you go into a rainforest and you just look at thousands and thousands of plant and animal species in the rainforest, that's what you've got in your gut. we need to find out what is the effect of the space environment. And so Scott was the wonderful opportunity because he was up there for a year. If there's no changes in the microbiota from the beginning to the end of the mission, that's a good sign that we don't have to worry maybe about the fact that going to Mars and back over a 2-year period is going to be a problem. But if we find that there are certain bacteria that are outcompeting other bacteria in the zero-gravity radiation environment, well, we've got to perhaps come up with countermeasures then.
The International Space Station's Destiny module is home to the Microgravity Sciences Glovebox. It's an enclosed space for experiments that involve potentially hazardous materials. In this Speedy Time segment, astronaut Peggy Whitson pulls the rack out of the wall to show us how the MSG works.
The sweet smell of life support. Presented by Science at NASA. When NASA astronaut Kjell Lindgren blasted off from Kazakhstan in July of 2015 for his first expedition aboard the International Space Station, he had some lofty expectations.
I was eager to see Earth from space, and I couldn't wait to float in microgravity.
And he confessed.
I kind of expected the International Space Station to smell like a locker room.
After all, what would you expect? It's an airtight spaceship continuously occupied 24/7, 365 days a year by as many as half a dozen hard-working and exercising astronauts. Lindgren was in for a surprise, however.
The air in the space station actually smelled great. The filters and the life support system do a great job cleaning the air. There were no issues at all.
First contact with the space station's clean air reminded Lindgren, a flight surgeon, of the impressive technology underlying the station's life support system.
On the International Space Station, we're testing technologies that will allow us to live comfortably during long journeys into the solar system. Our life support systems provide a properly pressurized atmosphere with the right amount of oxygen. It scrubs carbon dioxide from the air, it keeps the temperature in a comfortable range, and provides fresh water and light and everything that we need for good hygiene.
Hence, the sweet smell of the air.
While I was on the International Space Station, I felt a lot like a bridge builder, helping to pave humanity's path to Mars.
As mission planners look toward the red planet, we are definitely evolving from the lessons learned on ISS, says Molly Anderson, a principal technologist at NASA. We want to increase the level of recycling wastes beyond what we do on the station now. Our ISS water system can recycle about 93% of the wastewater back to clean water. The leftover fluid is referred to as brine, and we're flying a demonstration technology on station soon that will recover most of that water too. On the station, if all the systems are working, we can recycle a little less than 50% of the carbon dioxide back into oxygen. We're trying to get that number much higher, to at least 75%, and even up near 100%, she continues. While the space station still relies on cargo vessels to bring fresh supplies and equipment, improved life support systems can help reduce those needs, leaving more room for science and science equipment going to the station. Plus, Earth won't be able to help on missions that leave Earth orbit.
Hundreds of millions of miles from Earth, no one will be able to bring us fresh water or replace malfunctioning systems. We will be on our own, just us and the life support system.
That's why it is crucial for life support development to proceed aboard the station, an excellent testbed for future deep space flight. For more from the International Space Station, go to www.nasa.gov/station. For more news about the sweet smell of spaceships and the systems that support them, stay tuned to science.nasa.gov.
Those are systems that help support the astronauts on board the station. There are other systems that the astronauts use to do science. And because this is so fun, we'll take another shot at showing you astronaut Peggy Whitson pulling the Microgravity Sciences Glovebox out of the wall and showing us how it works.
Today,
We wanted to talk to you about Microgravity Science's Glovebox. We do all kinds of experiments in here. I've grown tissue culture cells. I've looked at how air and fluids separate. I've grown superconductor crystals in here, and they got up to over 700 degrees Fahrenheit. So this environment was to protect us from what was happening inside the experiment. Now I'm growing cells, and they have to be grown in a sterile environment. So now I'm protecting the cells from me by having them inside this environment. So it's very flexible, and we can change out all the experiments by opening up this big door on the front. Then once we've got the experiment set up inside, you can access from the sides, or we have this little airlock down here that if you wanted to, you could access from here as well. It's kind of like a transformer. At the end of the day, when you're done working with it, you just push it back into the rack. There we go, and it fits right in very nicely within the rack volume. The other thing that goes along with this, or is attached to this, is a microscope. We have a fantastic microscope with capability to send the videos and pictures down to the ground. The ground's been looking at the structures that are forming differently here in zero gravity. That's why they're doing the research here, is to see what new they can discover. So very cool science, very cool piece of hardware. Microgravity Science's Glovebox.
So we have science in the lab that benefits people on Earth. There is also supporting future exploration efforts. There is encouraging international cooperation. And another top priority of the International Space Station's mission is enabling the commercialization of space flight and space research. Being a destination on orbit for flights from commercial companies really helps with that. Well, now, in conjunction with NASA's Commercial Crew program, the station is moving the nation closer to the goal of restoring our capability to launch astronauts to space from the USA.
Stand by for terminal count.
Stage 2, pressing for flight.
5, 4.
The purpose of the Commercial Crew program is to return to our nation the capability to fly our astronauts to the International Space Station.
Ground gas closeout there, please.
3, 2, 1.
This Commercial Crew program is the beginning, I think, of an entirely new era.
Go for launch. Side booster ignition.
Liftoff. Astronauts taking flight once more from American soil as the nation begins a new chapter of space exploration.
Stage 1 propulsion is nominal.
This is us as a nation. This is us as a NASA private-public partnership together, allowing our nation to capitalize on what they've invested in within NASA to be able to create this industry.
Both of our companies, Boeing and SpaceX, are incredibly capable companies.
It's just an awesome feeling to see the hardware coming together and seeing, the excitement of the technicians, of the engineers.
It's going to be wonderful to see the crowds come back. And this is great, to get the public kind of re-engaged on human spaceflight again.
The Commercial Crew program is revolutionary in a sense where it's going to provide us the opportunity to have more astronauts in space. It's going to further our ability for knowledge in a microgravity environment.
We need to explore, we need to pioneer, we need to see what's out there and find new places to live.
The International Space Station still has a lot to teach us.
I think we're going to have a lot more opportunity to do the exploration research that we need to get us to the moon and to Mars and beyond.
There's a larger group of us that are dreaming that potentially could have a ride someday and be working in space.
It's a huge goal, a huge accomplishment for both for partners, NASA and the United States of America.
The fact that we're able to partner with commercial industries allows us to fulfill that mission, to be explorers, because we can work together.
This is just the beginning.
I know the greatest events in space exploration have not happened yet, and that our destiny lies above us.
You're looking once again at a live view inside the International Space Station's flight control room, located at NASA's Johnson Space Center in Houston. This facility has hosted flight controllers since the mid-1960s. Not the same ones, of course. There have been a succession of NASA programs that have led human exploration of science out of this room. People often wonder what goes on in this room on a day-to-day basis. So, we caught up with Flight Director Mary Lawrence, got a chance to ask her about a whole bunch of things.
Hey, Flight Director Mary Lawrence.
Oh, hey.
Do you think you have a few minutes to tell us everything about Mission Control Houston?
Sure.
So can we follow you into the control room?
Yeah, let's go. I'm about to start my shift.
So what's it like in Mission Control?
We fly spaceships. It's awesome.
Do you have a shift every day?
Not every day. I have a string of shifts every few weeks.
How many shifts are there per day?
3.
And how many other flight directors are there?
There's 26.
Oh man, I hope I'm allowed back here. So what exactly does a flight director do?
The flight director is the lead of the flight control team, so they're the final decision maker in all human spaceflight operations.
What's a flight controller?
They do all the work.
What was your first day on console like?
It was pretty quiet. The crew was sleeping.
Is this Mission Control?
This is one of the back rooms that supports.
Oh, how many back rooms are there?
There's several.
How many people support the people in Mission Control?
Could be a handful, could be hundreds during busy times.
What is done in the back rooms that helps out the flight controllers?
They're kind of the second set of eyes. They help out the workload at each of the consoles.
Where's the real Mission Control?
In here.
Oh, can we go in?
Sure.
Whoa. So this is Mission Control.
This is it.
What mission is controlled here?
International Space Station.
Where do you control other missions?
Down the hall, around the corner.
How many control rooms are in this building?
There's 3.
How many people are usually in this room?
Could be 6, could be 20 some.
Is there assigned seating?
There is.
What do the patches mean?
These patches represent missions that have been flown out of this room.
What time does it close?
We never close.
How many mission controls support the space station across the world?
Primarily, there's 5 across the world.
So this is where the flight director sits?
It is.
Oh, hi.
Hi.
What's the hardest part about being a flight director?
Constantly being aware that there's 6 people on orbit who are dependent on you to keep them safe.
And the most rewarding?
Seeing them return safely to Earth when their mission's complete.
How many acronyms do you have to learn?
TMTC.
What did you study in school to prepare for being a flight director?
Mechanical engineering.
So, are there a lot of pilots that are flight controllers?
Some are, but it's not a requirement to do the job.
How long do you have to train to be a flight controller?
It takes about a year.
What's that training like?
Pretty vigorous. We simulate ISS onboard operations, only we break a lot more stuff.
They're called simulations, right?
That's correct.
How long can they last?
About the length of a shift, so about 9 hours.
What's the coolest part about working in this room?
Understanding all the history that's happened here over the years.
So when you switch shifts, how long is that handover?
About 30 to 45 minutes.
Are all the systems run from desktops?
That's correct.
Do you deal with the same software updates we do?
Yes, we have to keep our computers free from viruses too.
So what does this button do? Oh,
no.
Sorry about that. So what are you listening to?
They're called voice loops.
And how many people do you listen to at one time?
Hopefully only one if I'm doing my job correctly.
Does the flight director fly the space station?
Not exactly.
So who does?
Sir Isaac Newton does.
So is that true, Mary?
ADCO helps.
Oh, hey ADCO. So what exactly does ADCO stand for?
Attitude, Determination, and Control Officer.
That explains the bat. So how do you deal with orbital debris?
We use thrusters on the Russian segment and get out of the way.
Can astronauts fly the station from the inside?
They sure can.
Is there a cruise control?
It's a little more complicated than that.
Can you make the station do a barrel roll?
I could. I probably wouldn't be here much longer.
Do you need a spaceship driver's license?
That's my certification.
So, Mary, each flight controller looks at a specific part?
That's right. Everyone has a very specific responsibility as part of the team.
Does everyone talk to the astronauts?
Not everyone. That's Capcom's job.
I heard that you have to be an astronaut to be a Capcom.
Not all the Capcoms are astronauts. Some are former flight controllers or instructors.
So is there a phone number for the International Space Station?
Yes.
Could you just type it in my phone really quick?
We'll call you.
Oh, okay. Well, what is the time zone of the space station?
Greenwich Mean Time, GMT.
Why is that?
There's control centers all over the world, so we just picked somewhere in the middle.
What is a shift like when the crew is sleeping?
It's pretty quiet. We're mostly just planning for the next day.
Are you allowed food and drink in here?
Yes.
What happens if a flight controller gets sick?
We call someone else.
What happens if an astronaut gets sick?
They call the doctor here on the ground and take a sick day if they need to.
Oh, who's sitting here?
This is ground control.
What does ground control do?
Ground control is responsible for everything here on the ground.
Oh, hey, ground control. Is there any communication delay from the ground to orbit?
Not really.
And how often do you lose signal from the station?
A couple times per shift.
How long do those last?
Could be anywhere from 1 minute to 30 minutes.
What happens if mission control loses power?
We have backup power.
How high are the satellites that communicate with the station?
23,000 miles.
And how high is the station?
250 miles.
What's the official language on the station?
Actually, the remote interface officer would know that one.
Oh, it's English.
Do flight controllers know multiple languages?
Tak, конечно.
So Mary, how fast does the station orbit the Earth?
17,500 miles per hour.
Okay, give me some context.
So that's 5 miles a second. That's from here to New York City in 4.5 minutes.
Is there a speed limit?
Sort of. We don't have enough time for the details.
So how many times does the station pass over mission control every day?
Sometimes not at all, sometimes a couple times a day. We like to go out and wave hello to the crew as they pass over.
How many times has the station orbited the Earth?
Over 100,000.
Have you flown any other missions in this room?
This is the former shuttle flight control room.
So, what's going on right now?
This is called LOS. It's a temporary loss of signal. This is when we take our breaks.
And what do you get to do on those breaks?
We play Yahtzee. Just kidding. We get food, we go to the bathroom, we get coffee.
Do you think any future missions will be controlled from this building?
Possibly. Could be the Orion missions. EM1 and EM2 are flown from here.
What is the farthest any human has ever traveled?
We've been to the moon. So the Apollo 13 crew has been 250,000 miles from Earth.
Wow. What is the longest time a NASA astronaut has ever been in space?
Commander Scott Kelly was on orbit for 340 days. It's almost a year.
Wow, that's a long time. But how long will those Mars missions be?
Could be a year, maybe 2.
Wow. Okay. So one last question. Is failure an option?
No.
Well, thank you, Mary, for taking your time to answer everything about mission control. I'm sure there are more questions, but we'll save those for another time.
Sure.
Take care.
Bye.
If you'd like to get another look at any of the stories we featured today, check us out on YouTube and on Facebook, and the addresses that magically appear at this time each week. While you're at those addresses, take a look at the other cool stuff you can find about NASA and America's human spaceflight program. You should also check out Houston, We Have a Podcast, which features folks here at NASA talking about their work in all aspects of space exploration. The new episodes post on Fridays. Today, September 14th, Gary Jordan learns more about the development of the Orion spacecraft by talking with the people leading the effort to get ready for next year's critical Ascent Abort 2 test of the Orion spacecraft's launch abort system. Go to www.nasa.gov/Johnson/HWHAP, as in Houston We Have a Podcast. You'll find all of the episodes there. You can also listen on Apple Podcasts, on Google Play, and on SoundCloud. This is Mission Control, Houston.